Hello, everyone. This is Dr. Daudu here presenting randomized block design. Happy listening. Well, this is the second in the series of lectures on the design of experiment. In this video, I've avoided the audience having to install additional R packages inside out. These codes are reusable the way they are. Just run them. It doesn't matter the version of R you are using. I've also assumed that my audience are fully aware of the theory of RBD so that I can go to the computation directly. The reference material still remains Cochrane and Cox, 1957. Here, for this presentation, two data will be used. The first data. Here, this is on L1 cysts. It attacks oats. Now, the experimental plots are allotted at random to each of the fumigants. This CK, CN, CM, CS, they are fumigants. The O are control. Those are not fumigated. The readings above are for capturing the number of L1 cysts on the plot prior to planting. When the samples were captured, then after that, the oat was plowed in. Then it was nurtured, fumigated, and harvested. And after harvesting it, another sample was taken on the numerous plots. And this is the reading. The readings below are those obtained from the plots after harvesting. The entire experimentation, took place at Woodland State years ago. And the CN, CS, MP, CK are the abbreviations for the fumigants. Okay? The situation before is kept into L before. Then the situation after harvesting is kept in L after. The treatments, talking about the replicates, then the plots allotted to the fumigants. Data 1, data 2 are the data frames for L before and L after. You may want to see them, just type data 1 and hit the enter button. It will give you the data for the situation before. And data 2, in the button, it will give you the situation, the data for the situation after. Now, I computed the analysis of variance and asked for the summary of the analysis of variance. These are these two. This is the analysis of variance before, and that's the analysis of variance after. Now, after that, I also did generalized linear model as modeling L before treatment, L after treatment. The summary. This is summary for the L before. Now, the situation before was that CK, second dose of CK, you see that, and the control, first dose of CK, the second dose of CK and the control were at par. That means the second dose was inactive at all. It wasn't reflecting, but this was the situation. There are some weak ones too. First CM, second CM, very weak, but they are still effective. But these ones are stronger. 1 CN, 2 CS are stronger, and then 2 CN. However, this is captured by the situation before. Now, you see, if you do this if you use this technique, you don't have to do any means separation. This the regression will show you the means vis-a-vis the level of significance. Okay, this was the situation after. After the harvesting, all the fumigants run under, except first dose of CS, it is still shown in there, and sorry, the second dose of CS2. So CS is only CS that is very, very active on the plots. The others run below. Okay, there's also 1 CK. First dose of CK is still also reflecting. Okay, so that's the situation before and situation after. These are the fumigation. Now, as for the second data, it's about potash attached to, applied to plots. Again, is to attack pests, to prevent pests from attacking cotton. All right. That's the information about the data, and that's the data. That's the data. This is the uncalculated ANOVA for the data. Okay. Now, given that data, you can have the treatments displayed like this. These are the levels of application of the potash on acres of the farm. The replication, each is replicated 5 times in the wood. And there are 3 treatments. No, sorry, there are 5 treatments, but 3 replications. Now, this is the potash. Now, again, feed that with data frame written like this. And you can invoke that to see how R will take it. Then after that, a linear model. Treatment on potash. Treatment plus replication on potash was done. And this is the result of the linear model, the fitted linear model, the summary, fitted linear model. This is the result. Now, it tells you that all the levels of application of potash are very, very effective, except for treatment 54. In treatment 54, there are still some pests. Some pests were still noticed there. And then, so it's less effective as the others. Now, the ANOVA. The ANOVA is what you have in here, computed ANOVA. And this will compare effectively with the hand-calculated ANOVA. Mind it, our F value is this. Let's see the F value for the uncalculated computed, and you see the F value is also 4.19. This is the uncalculated ANOVA. And what we have here is the computer computation. So that's the farthest on RBD. Until next time, bye. Please like, share, and subscribe. Thanks for listening. Thank you.